Right. Right, ladies, gentlemen, traders, investors, crypto enthusiasts. There's another panelist. All right, so we spoke about cryptocurrencies. We spoke about NFTs. I'm not even asking why. Some people just love them. Some people can't live without them. I can. But anyway, let's continue, guys. Blockchain scaling and the next generation internet and cloud is the topic of the day. I know it sounds complicated, but our guest for today promised to make it very, very comprehensive for everyone. So let's give him a round of applause. Adam Waldenberg, co-founder at the Unigrid Foundation. Go ahead.
Thank you. Okay, so before I start talking, I'm going to run a little intro video to get you warmed up a little bit. So let's do that. I hope you guys have the sound under control. So I'm going to press play. Let's see what happens.
Tell me a bedtime story, Daddy.
Once upon a time, in the not-so-distant past, the internet was less stable.
Is it true the websites on the internet could go down back before I was born, Daddy?
Oh, it's true. Back in those times, the internet was controlled by big corporations. They had a big monopoly. Like vultures, they consumed and held your data hostage. They didn't care about outages because they knew there was nothing better.
That's terrible.
Yeah, it was. People accepted it because they didn't know that something better could exist. But then, sometime before you were born, things began to change. They called it the Renaissance of the Internet. Today, we're free, and we no longer have to worry about any of that.
Okay. I hope that was somewhat enjoyable. So yeah, I'm here to talk about blockchain scaling and the next generation internet. And as the presenter here said, I'm from Unigrid, and we want to change the way the cloud works and how the internet functions today, because there are a lot of problems and we really need to solve them. So that's why we're here. So let's talk about the situation we have today. I hope I'm not in the way here. And I want to talk a little bit about traditional blockchain solutions and how right now most of them, even the new ones that kind of try to solve a lot of problems, they still don't really get all the way. Almost every solution has problem with congestions on the blockchain and on a network. Yeah, and often the transaction volume is purposely limited to kind of handle that, so it doesn't get too bad. But as we all know, it's a big problem with some chains, and even some that are very well used today as well, like Ethereum, for example, with NFTs now, when they are so popular. We all know the minting fees. They are kind of like, I think to kind of mint an NFT, you kind of have to pay like $70 or something like that now, just for the minting, and that's not really acceptable. Yeah, and if you look at how they work, they always cause this unnecessary data retention. So you have a lot of excessive storage used, and you also have privacy issues because everything that you save on there is kind of stored there forever, and it's never going to go away. So, yep. So I'm going to talk a little bit about the central ledger, and that's what Bitcoin and Ethereum uses. And as I mentioned, everything is stored in one place. The transactions are limited. Either it's by block speed, or it's by the allowed space in the block. And everyone here kind of, or most of you, know how it works. And once something is in the chain, there is no way of going back. It's there forever. Yeah, and I mean, it results in massive, massive storage and also memory requirements in the software. For example, if you look at the blockchains that have a lot of blocks in them, they kind of have to save a reference and a hash map to every single block that's currently in memory. So it kind of causes a problem, and a lot of memory is used for something that is quite simple in its design. But I mean, how can we? One of the things we are looking at is how can we make this better? How can we improve it? And how can we move the blockchain market forward? So, if we look at some of the solutions that other projects are employing, the first one is just increasing the block size or the block speed, and obviously that doesn't really work, because when you do that, often the source code isn't even designed to kind of handle that, and you get even a bigger problem and even worse congestion than you had before. I'm not going to name anyone, but let's just call them forks of Ethereum, did exactly this, and it's causing massive problems. And the chain is continuously going down, and it's just, yeah, it's a huge problem. So don't do that. So another solution, of course, is to introduce sidechains, just to kind of improve scaling. So instead of just having a central ledger, you have one or many sidechains that kind of help the central ledger to handle all the data and all the transactions. That's a solution that kind of works better, but you're going to reach a point where the central ledger still becomes the bottleneck, because it won't be able to handle all the sidechains eventually, once the network grows enough. So all these projects that kind of do this, they are going to hit the wall eventually. So it's not a final solution to the problem, and we need to find something else. So another that, for example, Ethereum has been trying to do for the last, I think, 4 years or 3 years, is to shard the central ledger and kind of have one blockchain that is divided into pieces. So that hasn't really worked out either, because it adds complexity to something that is very simple at its core. So that's probably not the way to go. And we kind of have another solution that is very different, that you probably haven't seen before, that we're going to get to. But yeah, so this is kind of the current situation on the market and what other projects are trying to do. And again, this design and the way that the blockchain works, they kind of keep it to the original idea that Satoshi Nakamoto did when he developed the first data structure and did it the first time. The blocks always, they are always kept, and it's always in there forever. And of course, when you do that, you throw privacy out the window completely. Some could argue that the blockchain is kind of private, but if you look at it and how for example, the European Union defines it, all transaction data and all transaction information is personal information. So that means that every single blockchain project out there is currently in breach of the GDPR, And that's a huge issue at the moment, and it's something that is being talked about within the European Union at the moment. The question is, do we have to change GDPR and kind of say that, yeah, transaction data, it's fine, we can kind of share it with everyone? Is that something we want? Or do the blockchain project have to change and kind of adapt? So that's an open question to consider. Yeah, so just to sum it up, everything that we talked about here, traditional transaction-based blockchains are really easy to congest. They have problems. They are not suitable for data and application storage. So all this use of smart contracts and all this data that is being stored on Ethereum and smart contracts and everything, you can see the problem it's causing with NFTs and also with the smart contracts that are floating around. The transaction fees are astronomical, and it's just going to get worse unless we kind of find a better solution. So think outside the box is what I want to say. And something else that is a problem today on the internet, I'm going to call them the cloud mafia. So the current internet is dominated by, as you all know, 3 really big companies that kind of control almost all communication right now. I think they kind of hold like 70% at this point of the communication on the internet goes through these 3 companies. And yeah, it's causing problems because things are stored in some huge data center somewhere, and when it's easy to disrupt, it's easy to attack, and it makes the data and the services vulnerable. Because you can more easily take them down compared to if they are spread out. And if you think about it, even today with the blockchain movement, if we are trying to decentralize everything here, they are kind of pushing everything in the opposite direction and working against us. We try to decentralize, they move everything into a data center in some country. And it just gets worse and worse, and it's like we're pulling from one direction each. So can we kind of do something about this and solve it somehow? Can we fix the internet? Is my question. Can we break the monopoly? And can we add the redundancy needed to kind of push for the adoption? Because I think to kind of break that monopoly, you kind of have to offer something that they can't offer. And one thing you can offer is redundancy, full and complete 100% redundancy. If it's done correctly, you have something that these giant corporations currently cannot offer you. Not without it costing a small fortune for you. So kind of how do we do that, and how do we solve it? Yeah. So as I covered here, if you want that from the cloud providers, you usually have to pay like extra charges. And one thing to also consider is, can you actually trust them? Can you trust them with your data? Do you know what they are doing with it? Do you know how they are storing it? Do you know how safe it is? It's something that I think most people don't even think about, but it's really important. And one day, it bites you in the ass. Because something happens at the provider, and you lose information, you lose data, and yeah, they didn't keep it safe for you. So like I said, even with the movement of the blockchain movement, in a way, centralization is still kind of increasing. But I think we can do something about that. So, yeah, I'm going to run, so you don't have to listen to me constantly here. I'm going to run a video. And you can watch that in between.
Your freedom and privacy on the internet and in everyday life is under attack. You might not even know it. Centralization is increasing, with more and more servers ending up in huge data centers owned by just a handful of corporations. When services and servers get centralized, it threatens the stability and trust of that network. What happens if these businesses one day face regulatory problems? Or if a country where one of their data centers are running come under the control of a totalitarian regime or government? Will you be able to trust them to keep services running? Can you trust them to keep your data safe? What if their services or data centers get compromised? They might unintentionally leak your private data without even realizing. Not to mention the amount of malware and spyware is increasing every year. How do you know they aren't infected? There is also the very real threat of intentional monitoring and theft of data from the provider. Can you trust businesses whose sole purpose is monetary gain? It gets worse the longer you look. Personal data that governments store, such as healthcare data, medical records, criminal records, are at an increasing rate being stored offshore in major data centers. Not only is your data more vulnerable, but those services become easier to disrupt. Picture this. Every week, Joe visits his local psychiatrist, Jane. He tells her his most cherished and private thoughts, topics that should be confidential between him and Jane. Jane meticulously stores her patient records via an external provider that provides a journaling system for health centers. What Jane doesn't know is that the data is stored on an unencrypted server in a huge data center in the US via another provider. If there's a breach or data leak of any kind with the server provider, all of Joe's patient records risk being leaked onto the internet, along with every other patient that Jane has met. Furthermore, the server provider has insufficient backups, so if something was to happen to the server, Jane would lose all her patient records permanently. This perfectly describes the problem we are facing. Not only are people and governments unaware of how deep the problem runs, they trust the providers to do a good job and keep their data safe. Unfortunately, there are just too many points of failure. This is one of the reasons why the Unigrid Foundation was started. Like everyone else, we also want to be safe on the internet and in our everyday social life. We shouldn't have to worry that everything about us will be leaked by a third or even fourth party just because we use their service. With Unigrid, providers don't have to implement and add encryption and security on their own. Instead, the Unigrid network automates this process, encrypting, securing, and sharding data and services in a fault-tolerant and redundant way. Rather than relying on separate businesses, the internet becomes a global service where everybody can participate and store data.
Okay. Right. So that's kind of what we are about and what we are trying to do. We're trying to basically create a global cloud service that is always online, that can never go offline, and that you can trust permanently. And that's kind of what we want. It's actually something that's really close to my heart because it's around 2016, I started a data center in Gothenburg, and I've been experiencing these problems firsthand myself. And that's kind of where this idea comes from. That's how we ended up here. It was always a struggle for customers with, they had to do extra backups and extra redundancy to kind of keep everything safe and up and running. I couldn't provide that from my centralized location. It's just not possible. So they kind of have to spread out all their services and all their data. And is that really how it should work? Should a company have to be forced to think about that? Or should it be something that just comes naturally? That's part of the backbone of the internet. So yeah, so we want to make a democratic network that anybody can join, make it autonomous and scalable. Obviously, it should be able to scale after use. So it's important that it can expand as more users join. And no limit to transaction speeds whatsoever, because that doesn't work. You can't do that. You're always going to end up with problems if you try to limit that part. And yeah, and we kind of want a network that can support compute work, storage capability, and also provide anonymous internet access via So via a in-memory blockchain that people can access the internet via. So, and one more thing, the core design of this network is transactionless. We don't require transactions in the traditional sense. Even if it's even if it uses blockchains, it does not need transactions. So that's a big difference from what you are used to with other projects. Yeah, and it's also about helping certain countries or certain people in certain countries to kind of get away from the censorship. Even in Western countries, we are censored from accessing some websites. If you're in the US, for example, some European websites are off limits. If you're in Europe, some US websites are off limits. I don't think it should be that way. And it's also a way to stop oppressive regimes from locking people out from services on the internet. And we sure know that there are a lot of them. And we can do something to help the situation. And yeah, just give everyone on the network full control of their own data. Everything stored on this network, if you store it there, you can be sure that it's always going to be there, and only you can access it. Nobody else can take it down, only you can take it down. As long as you finance the blocks where it's stored, that's it. It's going to always be there. And that's also a kind of a big difference from some other services out there. You don't want oppressive regimes to kind of be able to take all your information. Yeah, so how does this work? What are we doing to kind of achieve this? And what actually is Unigrid? So what we are doing is that rather than using a central ledger, we are using really, really small blockchains. And we spread the data out in really, really small shards. So each blockchain holds a little bit of information, and it's kind of split up. And the idea is to allow anybody in the world, if they have a little bit of a Unigrid, they can run a node and contribute resources to the network, and they get some rewards back for what they are giving the network and the rest of the world. So it works like this. So now we're turning a little bit nerd. I hope that's okay. And if you are familiar with how RAID arrays work, the concept is similar here. We kind of, let's see if I can see it doesn't really work that well. But each of these in this representation is actually it could be represented as a shard group or a blockchain. So we kind of store some data in each blockchain, and then we introduce parity blocks. Those would be the red ones. And in this case, in this little example, it doesn't, in real life it would be much bigger. But in this example you have 5 chains, and 2 of them can go offline, because we introduced 2 extra parity blocks in the information. So 2 whole blockchains can disappear, and your data is still intact. So that's kind of how it works. And it allows us to kind of do really, really, really small blockchains and really have many of them. Instead of having just one big, unscalable monstrosity, we kind of have these small, small pieces that we can scale indefinitely, and we can just add more blockchains to the network. Yeah, and the only acceptable measure for transactions per second, that would be infinity, right? Anything else is not good enough, in my opinion, because then you can potentially run into a wall. And as I mentioned before, the grid nodes on the network get the reward for the work they contribute, and they are scored by the network. So a node that performs better is going to get more rewards than a node that performs worse. So on this network, it's going to be an open competition, basically. The better the nodes that you put up, the more rewards you get. But theoretically, you could also run a node on a toaster if you wanted to. It just wouldn't perform that well. But it would still contribute something to the network. And I'm going to run another video. Joe is the narrator in the video, if you wonder who that is. So here is the next one.
The Unigrid network and the underlying protocol have the power to render various data communication and storage market segments obsolete or completely redundant. In the same way streaming services rendered physical media obsolete, the Unigrid network makes anonymization networks, VPN providers, backup services, storage services, and cloud service providers completely obsolete. That's a bold claim, but we stand by it. Let's take a look segment by segment. Goodbye backup providers and secondary storage solutions. The Unigrid network is backed by a collection of blockchains that use striping and parity blocks to ensure data integrity and achieve fault tolerance and redundant storage. Grid nodes on the network organize themselves into shard groups, with each individual shard group governing exactly one blockchain. The Unigrid network uses the shard groups to create storage arrays similar to legacy RAID arrays, but using blockchains instead of SSDs or disks. Each entry then either contains data or parity information. The result is a network where the data you store can never disappear by accident or sabotage. Why use risky traditional storage when you can back up your data once, securely, forever? Goodbye VPN providers and anonymity networks. The Unigrid network provides anonymous network access not only to the Unigrid network itself, but also the ordinary internet. The Unigrid network is more resistant to eavesdropping than systems like Tor, as it uses in-memory communication blockchains and shard groups to achieve anonymization. While Tor uses traditional onion routing, the Unigrid network uses fingerprinting and its underlying communication blockchains to achieve anonymity. Unless you can scan the whole network at the same time, it's impossible to know who initiated data traffic. Nodes and grid nodes forwarding traffic are completely indistinguishable from the node that actually originated the traffic. Not only is the network inherently anonymous, it's not run by a company that could well sell you out like a VPN. Anonymous, secure, and trustworthy. Why go anywhere else? And goodbye cloud service providers. Finally, the Unigrid network and the Unigrid Foundation also intends to address the currently very costly cloud services on the market. Unigrid network participants provide compute cycles and storage not only from data centers, but also from home servers and home connections. This gives the network the potential to provide similar services at a fraction of the cost. The Unigrid network rewards the nodes on the network when they provide these services, and the cost of these services relies on the exhaustion level of the network. If there are a lot of free resources, the cost for the end user goes down. If the network is highly loaded with less resources available, the cost for the end user goes up. This is how the network regulates itself and controls how much the grid nodes get rewarded when they provide their services. The fact that anybody can join the network and provide their computing resources to it creates a truly open market that regulates itself and keeps costs for the end user down to a minimum. Cloud providers would be forced to either close down or join the Unigrid network and provide their services under the same conditions as the rest of the Unigrid network. The Unigrid network has the potential to change the IT industry and the way we work. It gives end users the ability to store, view, and use their data directly from their own computers without the need of having to rely on or trust external service providers. They can put their trust into the design of the network rather than relying on the assurances of an external company. We welcome you to the next natural step in the evolution of the internet. Visit the Unigrid website to learn more about the network, its development, and what's currently happening at the Unigrid Foundation.
Okay. Yeah. So, one of the big things when we move forward here is market adoption, obviously. That's a big one. And how do you achieve market adoption with when your competition has such a big dominance? If we look at some other blockchain projects, it's really, really difficult for them to kind of reach any adoption level whatsoever. they kind of just stay these small niche solutions. And obviously, that's not what we want to do. We want to kind of be the dominant cloud provider of the world, if we can. That would be ideal, obviously. But yeah, we can't focus solely on the blockchain market because that won't allow us to reach any adoption whatsoever. It's still kind of, by many traditional companies and also VCs, it's still kind of considered a bit of a joke. Obviously, it's not. They need to wake up because a lot of stuff is happening in this sector. But they are slowly catching on, as you all know. But what can we do to push market adoption? What's the silver bullet? That's the question. And one of the things that we plan on doing is actually to support Amazon's full API suite. So we're going to support S3 and all the other endpoints and APIs that Amazon has, and allow people to move over easily to the Unigrid network. And as you know, I don't know if you know this, but if you look at other projects, like for example Filecoin, that's a really interesting project. They were completely community funded. It was 100% crowdfunded from the beginning. But what's interesting there is that they are able to, if you compare to Amazon S3, they are able to offer the same storage space for 0.02% of the cost that Amazon offers. And I mean, that's just insane. So there's a reason why this company is so big. They are leeching on the world, and we need to do something about it, in my opinion, at least. Yeah, so we are currently having our funding round, and it's going really well. And you can check us out here, obviously. And there is also a main website. We should have had it here, www.unigrid.org as well. And if this is something that is close to your heart, you should join our community and push for this, because I think it's really important, and we need to do something to improve the current situation. Yep, and I want to thank our 100 backing angels that we have on this project. Thank you for supporting us. Some of them are watching, I know that. Some of them are even here. Thank you for your support for the project, and let's change the internet and make it better. Thank you.
Right, what a nice presentation. What a nice presentation. Adam Waldenberg, everyone, co-founder at the Unigrid Foundation.